Let's dive right into the incredible, invisible, and totally epic physical journey of electricity.
Seriously, how does power actually make that massive trek to reach your everyday devices?
It starts with loose electrons getting pushed from atom to atom through a conductor, like copper.
Over at the power plant, heat, water, or wind is used to spin these massive turbines.
That creates electromagnetic induction. Basically, spinning magnets push those electrons through a wire to generate power.
Now, to get this journey, think of voltage as the pressure pushing electrons down the highway.
Current, measured in amps, is the actual rate those little electrons are flowing.
And resistance? That's how much the material fights the flow, which inherently creates heat.
These three connect through Ohm's law. And remember, you absolutely need a closed loop for current to flow.
Now, here's a crazy fact. Power plants actually only generate a few thousand volts initially.
If we sent power long distances like that, wire resistance would waste massive amounts of energy as heat.
So transformers step the voltage way up to hundreds of thousands of volts for the transmission highway.
Why? Because higher voltage means lower current, which saves us massive amounts of energy. Now let's quickly compare two types of current on this journey, alternating current and direct current.
Grids rely exclusively on AC because those magical voltage transformers, they only work with alternating current.
Wildly, US AC reverses direction 60 times every single second, or 50 times in most other countries.
Exiting the highway, transformers step that voltage back down at local substations and again at nearby poles.
This safely drops the electrical pressure to a totally standard 120 or 240 volts for your walls.
It enters through your usage meter and breaker panel, branching safely into your individual circuits and outlets.
Plugging a device in and turning it on completes the circuit, allowing those electrons to finally flow.
The device's internal resistance then takes over, converting that electrical energy into heat, light, or motion. Interestingly, solar panels produce DC, and your phone chargers actually adapt wall AC back into DC.
So look at your nearest plugged-in device. Can you picture the epic journey those electrons just took?